Good morning, everyone. Today, I, Mr. Neeraj Upadhyay, is going to conduct your first mathematics class for this session. So, first of all, let me welcome you to the DPS online class for the session 2020-21. Today, I am going to begin my first lecture with the chapter Real Numbers. Now, let me tell you one thing that this particular chapter is a continuity of the chapter which you all have studied in class 9, and the name of the chapter which you have studied in class 9 was number system. So let me recap few things which you all have studied in class 9. So I begin with the first topic, and that is natural numbers. Natural number is a set of, or we can say natural number is a collection of all counting numbers. And symbolically, set of all natural numbers is denoted with capital N. So you all know that all counting numbers means numbers starting from 1, 2, 3, 4 and so on up to infinity. These numbers are called natural numbers. Number 2, whole numbers. Set of all whole numbers is denoted with capital W. So here what I need to do is I need to write down all the natural numbers and just include one extra number, that is 0. Number 3, integers. Now what are integers? First of all, symbolically integers is denoted with capital Z or capital I. So here what you do, write down all positive natural numbers, all negative natural numbers, and then include number 0. Okay. So we come to the conclusion from the three things, we come to the conclusion that all natural numbers are whole numbers and all whole numbers are integers. Clear? Next, let's move ahead. Point number 4 now, fractions. So what is, like, I'll just give few examples like 2 by 3, minus 3 by 2, 1 by 5, 6 by 8. These are fractions where you have a number in the number above the slash, which is called numerator, and number below the slash, that is called denominator. So these are all fractions. Number 5, we have numbers which is in square root, which is in cube root. Okay, let's take cube root of 8. We have a numbers which is a perfect square. We have a numbers which is a perfect cube, like cube root of 27. So these numbers are these are the numbers which you all have studied in class 9, till class 9. Okay. Now before starting and moving ahead with the topic of class 10, that is the real numbers, let me explain you one thing, that any number divided by 0 is undefined or not defined in mathematics. It is undefined, or we can say not defined in mathematics. Second, if you find square root of negative number, this is called imaginary number. Imaginary means this is not real. Like for example, suppose if you have square root of minus 2 or square root of minus 4, this is not real. Okay. So suppose if you get something like this, you can simply, you can keep in mind that these numbers are called imaginary numbers, means they are not real numbers. Now, in order to explain you this real numbers, let me first of all, so these are the things which you all have studied in class 9, and just keep in mind these two things, that any number by 0 is not defined or undefined, and square root of negative number is called imaginary number. Now, so in order to explain you real numbers, let me first of all show you one tree diagram of the numbers in the number system. So I start with the first thing, that is complex number. And how will I define a complex number? All real numbers, all imaginary numbers are called complex numbers. Now what is imaginary number? I have just explained you that, and you keep in mind that in class 10 this much is sufficient to know that square root of negative number is called imaginary number. Okay, so I'll not go in detail. You will have this particular topic in your higher studies, higher classes. So I'll not move in detail about what is imaginary number. Just keep in mind that square root of negative number is called imaginary number. Next, now what are real numbers? So the topic is real numbers. Okay, so what are real numbers? Real number is a collection of all rational numbers and irrational numbers. It is a collection of all rational numbers, or we can say it is a union of all rational numbers and irrational numbers. So if a number is rational, it is also real, called real. If a number is irrational, it is also real. If it is a sum of rational, irrational, difference of rational, irrational, it is also called real. So we can say that collection of rational and irrational numbers are called real numbers. Now let us classify real numbers. We have classified rational and irrational. Now let us move ahead. Now what are rational numbers? Now see, whatever number you write in the numbers till class 9, whatever number you have written, like 2 by 3, just write random any numbers, like, but don't write two things. What is that? Those two things are any number by 0. Clear? These two are exceptional things. Any number by 0. Don't write this because this is undefined. And the second thing, this is called undefined. And the second thing, don't write square root of negative number, because square root of negative number is called imaginary number. Now, except for these two things, if you write randomly any number like 2 by 3, square root of 4, square root of 3, cube root of 7, 24, minus 1, minus 2, 3 by 2, these all numbers are real numbers. So that's why now I would like to classify. First of all, I would like to explain you what is a rational number first. So these are all, real numbers. So let me classify these numbers on the basis of rational and irrational. So first of all, let me explain you what is rational. See, rational number is a number which takes the form a by b for b not equal to 0. And always the nature of these type of numbers will be terminating. Okay everyone, what? Terminating. Or the second thing, non-terminating, repeating. What will be the nature of irrational numbers? The nature of irrational number will be non-terminating and non-repeating. Clear? Now what is this non-terminating and non-repeating? And here what do you mean by terminating, or it takes the form non-terminating, repeating? Let's first of all complete this tree diagram first. Now, so after that we can classify rational numbers as integers and fractions. I'll not move ahead because after integers I have already explained you that all natural numbers are whole numbers and all whole numbers are integers. In fraction, we can further classify it as a proper fractions, improper fractions. What is a proper fraction? It is a fraction where the value in the numerator is less than the value in the denominator. It's called a proper fraction, like 2 by 3, 3 by 5, and so on. What is an improper fraction? Improper fraction, we find that the value in the numerator is greater than the value in the denominator, like 5 by 2, 7 by 3, 3 by 3. We can say that it is also an improper fraction. Okay, so we have completed this tree diagram. Now let us study in detail about rational number and irrational number. And the main objective of today's class is to explain you all that rational number is a terminating, non-terminating, repeating. Means it can either take the form terminating or non-terminating, repeating. What do you mean by this? And irrational number takes the form non-terminating, non-repeating. So what is this? Before giving you example of irrational, let me explain you these topics first. So we move on to the next topic, second part, and that is, the second part is rational numbers and their decimal expansions. This is the second topic. Rational numbers and this decimal expansion. So just now I explained you that a rational number either takes the form terminating decimal or non-terminating and repeating, that is recurring. Means here you will find that a particular set of digit repeats itself. Okay, repeats periodically, we can say. What do you mean by repeats periodically? Repeats periodically means like you will find that after decimal, in non-terminating repeating, after decimal you will find a set of digit which will keep on repeating. Periodically means you will find that after decimal you are finding that 3, 3, 3, 3 keeps on repeating, and it goes on till up to infinity. So what we can do, we can represent this in the form 2.3, and on top of that we can give one bar. Like the second example, if I'm giving here like 2.23, 23, 23 and so on till infinity. So I can represent this in the form 2.23, and on top of that I can give bar. So here you are finding that a set, I said you that a set of digit will keep on repeating. So what is that set of digit here? 3. Here what is that set of digit? 23, 2, 3. So this is repeating itself. So I am giving on top of that bar, and so this is the equivalent representation for this 2.23, 23, 23 and so on up to infinity. So this is the meaning of non-terminating and repeating. So the numbers like 1 by 3, 2 by 7, 7 by 24, these numbers are non-terminating, repeating. That is, if you divide 1 by 3 and express in decimal form, you will find that it will take the form 1.333 and so on up to infinity. If you divide 2 by 7, it will take the form 0 point something like that, 0.2 and so on. So we'll find that you will have a set of digit after decimal which will keep on repeating. Okay, now you will divide and check this. Now similarly you'll find numbers here in terminating decimal like 1 by 4. If you divide 1 by 4, you'll find that the numbers terminates after decimal, the digit terminates. 1 by 5 after decimal, digit terminates. 3 by 10 after decimal, digit terminates. Now I would like to explain you how without actual division, actually without dividing, how to check whether the rational number takes the form terminating or non-terminating repeating. There is a very simple thing by which we can check, and what is that? First of all, you keep in mind that that particular rational number should be in its simplest form. It must be in its simplest form. So suppose if you have a rational number of the form a by b for b not equal to 0, where a and b are co-prime means what? A and b, a by b is in its what? Simplest form. So what you have to do? First of all, you have to factorize the denominator. Suppose if I factorize the denominator like we have 2 square, and now check the denominator. If denominator can be expressed in the form 2 to the power m into 5 to the power n, where m and n are whole numbers, then we can say that it is a terminating decimal. Like here in this case, we find that we have 3 by 2 square, which can be written as 2 square into 5 to the power 0. So we can clearly see that this denominator, 3 by 4's denominator can be expressed in the form 2 to the power m into 5 to the power n. So that's why we can say that this is a terminating decimal. That is, after decimal, the digit will terminate. That is, if you divide, you'll find that you have 0.75. Okay, next. The second example I can take is 8 by 24. Let's take 24. 8 by 24. Now, first of all, you have to check whether it is in its simplest form or not. No, it's not in simplest form. And then what is its simplest form? It's 8 by 24 is 1 by 3. Now you find that denominator is not in the form 2 to the power m into 5 to the power n. Means apart from the factors 2 and 5, we have other prime factors like apart from 2 and 5. And what is the other prime factor which we find here? It's 3. And hence we can say that this is not a terminating. So what form it will take? It will take the form non-terminating and repeating. That is, if you divide 1 by 3, after decimal you will find a set of digit which will periodically repeat itself. So how to represent that? After decimal, you can represent in the form like I gave you example. Suppose if you have 2.13, 13, 13. So 13 periodically repeats. So you can write down 2.13, and on top of that you can give one bar. So same way you can represent this also. So till now we have understood like that a rational number can be either expressed in the form terminating decimal or non-terminating repeating. So we can also define a rational number as a number of the form a by b for b not equal to 0, where a and b are co-prime, which either takes the form terminating decimal or non-terminating decimal. But non-terminating, what type of non-terminating? Make sure that you have to also mention that non-terminating and repeating. Repeating or recurring means after decimal, set of digit will repeat itself. Okay. Now, what happens in irrational number? What is the nature of digit after decimal in irrational number? You will find that an irrational number cannot be first of all expressed in the form a by b. Every rational number can be expressed in the form a by b, but irrational number cannot be expressed in the form a by b. Next, it can neither be expressed in the form terminating nor non-terminating repeating. That is, it will have the form non-terminating, non-repeating. That is, suppose if I say root 2, you cannot say that it is 1.4314, and you cannot say that this particular digit will repeat itself after decimal. I mean, after these digits. So we find that after this you cannot predict the pattern. And so that's why what we do in calculation, we approximate up to 2 digit or 3 digit and we do the calculation. Like root 3, we take the value of root 3 as 1.732. We just approximate after decimal up to 3 digit or 4 digit or whatever. I mean, the accuracy we require, we approximate up to that, and we write down we do the calculation. But it doesn't mean that the value of root 3 is 1.732. Means it is not terminating. Make sure everyone. What is the form then? It is non-terminating and non-repeating. That is, after decimal, you cannot predict the pattern of repetition. Means here you will not find a set of digit which will periodically repeat. Clear? That is, if you have 1.732, after that you may have 1, 2, 3, 4, 5, 7, 8, anything like that. Okay. So we can say that the number which is not a perfect square, the number which is not a perfect cube, sorry, I mentioned here perfect cube, it's a square root. A number which is not a perfect square, clear? 3 examples, which is not a perfect cube, these numbers are called irrational number, because if you find out its value, you cannot have the form non-terminating, and it means it will have the form non-terminating and repeating decimal. Means it will not have the form terminating and or non-terminating repeating. I hope it's clear, everyone. Now let me clear this part everyone listen here very carefully. The value of pi, we take it as 22/7, is not the actual value of pi. Actual value of pi means we are using this as the approximate value just for to ease our calculation complexity and nothing else. But please make sure that the value of pi is not 22/7. It's just the approximate value which we take to ease our calculation and nothing else. Because pi I have written here in irrational, and this particular value 22/7 is matching the definition of rational. So don't get confused. This 22/7 is a number of the form a by b, which is a rational number. But the value of pi, I have already explained in the tree diagram. That is the value of pi, which is 3.141592. And after that, you cannot predict the pattern of repetition. So that's why this pi is what? An irrational number. E is an irrational number which lies between 2 and 3. So we have seen what is irrational number, what is rational number. So let me brief here once more one thing, that real number means collection of all real numbers is denoted with capital L symbolically, capital R, sorry. All rational numbers are denoted with capital Q, integers with capital I or Z, whole numbers with W, natural number with N, capital N. Irrational number has got no standard representation, but we can also represent in the form all real numbers except rational numbers are called irrational numbers. Means we can say that if from real numbers, if I remove all numbers which is not a perfect square, which is not a perfect square, perfect cube, then pi, then e. If you separate from real numbers, if you eliminate, if you separate, then the remaining numbers are rational numbers. Okay. Now the last topic of today's discussion is how to without dividing express any terminating decimal into decimal form. Like suppose we have 7/2 cube into 5. I'll show you one shortcut, and what you can do, you can apply this shortcut to directly express in decimal form. What is this? First of all, you make sure that this a by b, where b not equal to 0, is in its simplest form or not. Then what next? Check the power of 2 and the power of 1. Now as you all know that when power is same, when power is same, base gets multiplied. Okay everyone? So here the power of 2 is 3, the power of 5 is 1. Now amongst between 2, 3 and 1, which is the highest power? 3. So what you do, multiply numerator as well as denominator both by 5 square to match the power of 2 and 5. To match the power of 2 and 5. And for this what I am doing, I am taking the power of 2 and power of 5, and whichever is the highest power, I am making equal to that. So the highest power is 3. So I'll make the power of 5 equal to cube. Okay, power of 5, which is 1 right now, I'll make it 5 cube. So for that, what I need to do, I need to multiply numerator as well as denominator both with what? 5 cube. So we have 5 square, which is 25 into 7, divided by, you all know that power is same, and you have product sign in between, so we can multiply the base and write it as 10 to the power 3. What is 25 into 7? Let us multiply. It's 175 by 1000, and you can write this as 0.175. Similarly, the second one, we have 11 by 2 to the power 4 into 5 square. You have the power. So first of all, this is in its simplest form. Yes. Now what is the power of 2? 4. What is the power of 5? 2. Which is the highest power? 4. So we have to make the power of 2 as well as the power of 5 equals to 4. So in order to do this, let us multiply numerator and denominator by 5 square. So 5 square, if you multiply denominator, it will become 5 to the power 4. You have 11 into 25 by, power is same, base gets multiplied, so 10 to the power 4. 25 into 11 is how much? 572, clear, by 10,000, which can be written as 0.0275. And last, 23 by 2 cube into 5 to the power 5. What is the highest power of, what is the power of 5? 5. This is the power of 2, 3. Which is highest? In 3 and 5, it's 5. So our objective here is to make the power, both the power of 2 and the power of 5 equals to 5. So for this, I'll be multiplying numerator as well as denominator both with 2 square. Okay, why 2 square? Because 2 square into 2 cube becomes 2 to the power 5. So we have 23 into 4 divided by 2 cube into 2 square is 2 to the power 5 into 5 to the power 5, multiply. Okay, 4 3 is 12, 4 is 9, 10 to the power 5. So we can write 1 2 3 4 5, 0.00092. Okay, so this way we can express without, so I showed you shortcut method where you don't need to divide, you just have to express denominator in power of 10 to the power in multiple of 10, and then you can apply this to express in decimal form, this logic. Thank you. Okay, today I wind up today's class, today's discussion. Okay, today's discussion was introduction of real numbers. We have studied about real numbers, only about numbers today. In the next lecture, I'll be starting Euclid's division lemma. Okay, so thank you everyone. Have a nice day.